What if everything you thought you knew about reality, time, even existence itself was just the surface? There are questions so profound they've haunted the greatest minds for centuries. What is the universe made of? Why do we exist at all? And what happens when physics completely breaks down? Welcome to the vast unknown, where we explore everything beyond Earth, beyond what we can touch, see, or even imagine. Today, we're diving deep into the 5 biggest cosmic mysteries that continue to puzzle scientists and inspire dreamers alike. From invisible forces shaping galaxies to the secret history of our own existence, each mystery reminds us how little we truly know and how much we're still discovering. Let's journey through them, one by one. Everything you see around you, stars, planets, nebulae, galaxies, all of it makes up less than 5% of the known universe. The rest, we can't see it, we can't touch it, but we know it's there. Dark matter, about 25% of the universe, doesn't emit, absorb, or reflect light. It's completely invisible. We know it exists only because of its gravitational effects, like a hidden scaffold that holds galaxies together. Without it, galaxies would spin themselves apart. And the way it bends light, through a process called gravitational lensing, acts like a cosmic magnifying glass, revealing its presence even though we can't detect it directly. Then there's dark energy, an even stranger force making up roughly 70% of the universe. It's not just invisible, it's mysterious on a fundamental level. This force isn't pulling things together, it's pushing everything apart. It causes the universe to expand faster and faster, like a balloon inflating with no end in sight. What's even more bizarre, the more space expands, the stronger dark energy becomes. It's as if space itself is generating this force, like a built-in accelerator that makes the cosmos rush outward. No one knows why it's happening, but it is, and it's unstoppable. Despite decades of research and bold hypotheses, from exotic particles to quantum fluctuations, dark matter and dark energy remain our universe's greatest unseen rulers. For every particle that exists, there's an opposite, an antiparticle, equal in mass, opposite in charge. Electrons have positrons, protons have antiprotons, and when they meet, they annihilate, releasing pure energy and leaving nothing behind. According to physics, the Big Bang should have created equal amounts of matter and antimatter. But here we are, living in a universe made almost entirely of matter. Why? That's the matter-antimatter asymmetry problem. Somehow, in the earliest seconds of creation, the universe favored matter, just barely. For every billion particles of antimatter, a single particle of matter was left unpaired and survived. That 1 in a billion survival led to everything we know: stars, galaxies, you, me. The laws of physics are supposed to be symmetrical, but clearly they aren't. Experiments like those at CERN, including the Alpha and Alpha G projects, are trying to figure out how antimatter behaves. Scientists are studying anti-hydrogen atoms, trying to see how they respond to gravity and whether their spectral fingerprints match those of regular hydrogen. They're testing whether the universe itself treats matter and antimatter differently, because if it does, then our understanding of physics isn't just incomplete, it's fundamentally flawed. This mystery touches something deeply personal, our very existence. We are here not because the universe is fair or balanced, but because something tipped the scales ever so slightly in favor of matter. When we gaze into the night sky, we're not just looking across space, we're looking back in time. Light from the farthest galaxies takes billions of years to reach us. That's how we know the observable universe stretches about 46 billion light years in every direction. But beyond that, we don't know. We can't know, Not yet. Some scientists believe the universe is infinite, that beyond what we can see, galaxies continue endlessly, maybe even repeating like cosmic wallpaper. Others propose a closed universe, where space curves back on itself like a 4D sphere. In that case, if you traveled far enough in one direction, you might eventually return to where you started, without ever hitting a wall. And here's the twist. Because the universe is expanding faster than the speed of light, thanks to dark energy, there are regions so distant that their light will never reach us. Ever. They're being pulled away too fast. This means there could be entire galaxies, maybe entire realms of reality that we will never observe. Not because we lack the tools, but because physics itself has sealed them off forever. What lies beyond? It might be more of the same, or something radically different. Different laws, different constants, a different kind of space. It's not just a boundary of distance, it's a boundary of knowledge. Few things in the universe are as mysterious or terrifying as black holes. These regions of space are so dense, so gravitationally intense, that nothing, not even light, can escape their pull. At the heart of every black hole lies a singularity, a point of infinite density where the very fabric of space and time breaks down. It's here that Einstein's equations collapse and our current understanding of reality fails. Crossing the event horizon, the black hole's outer boundary means no return. Inside, time and space behave strangely. Some theories suggest they even switch roles, with time pulling you inexorably toward the singularity. But perhaps the most mind-bending issue is the black hole information paradox. According to quantum mechanics, information about a physical system can't be lost. But when something falls into a black hole, where does that information go? Is it destroyed, trapped, encoded on the event horizon itself? This paradox reveals a fundamental conflict between general relativity and quantum mechanics, two pillars of modern physics that refuse to cooperate under extreme conditions. And what if black holes are more than just endpoints? Some theories suggest they could be gateways to other universes, or even the seeds of new universes themselves. Could each black hole be a cosmic womb, birthing new realities? No one knows, not yet. But we do know this: black holes are not just exotic objects, they're testing grounds for the deepest questions in physics. The Big Bang wasn't just a moment in time, it was the birth of time itself. It marked the beginning of everything we know: space, energy, matter, even the physical laws that govern our universe. But contrary to its name, it wasn't an explosion in space. It was space itself expanding, from a singularity smaller than an atom, infinitely dense and unimaginably hot, into the ever-growing cosmos we live in today. In the first few moments after this expansion began, the universe underwent rapid inflation. Temperatures cooled just enough to allow quarks to bind into protons and neutrons, forming the building blocks of atoms. Over time, those atoms came together to form stars, galaxies, and the rich cosmic tapestry we now observe. We know this story through evidence like the cosmic microwave background radiation, a faint, ancient glow, essentially the baby photo of the universe, captured just 380,000 years after it began. But even as the Big Bang explains how the universe evolved, it leaves us with haunting questions. Why did it happen at all? What existed before it? Was there a before at all? Could this be one universe among countless others? An infinite multiverse forever bubbling into existence? We're not just studying space, we're chasing creation itself. Each of these cosmic mysteries, dark matter, antimatter, black holes, the edges of the universe, and the moment of the Big Bang, does more than challenge our science. They challenge our imagination. They push us to the very edge of human understanding, reminding us that for all our progress, We are still beginners in a vast, unknown ocean of knowledge. But that's the beauty of it. Not knowing isn't a weakness. It's an invitation. Every question without an answer opens a door into deeper curiosity, deeper awareness, and a deeper connection to the universe around us. We are not just floating observers in space. We are conscious beings made from the same elements as the stars, gifted with the rare ability to look back and wonder. And in that wonder, we ask the most human question of all: why are we here, and what else is out there? What if we're just scratching the surface of something even deeper, more profound, and more mind-bending? Click on our next video to explore the Great Filter Hypothesis, a theory that might explain why alien life is so rare, or why we might be next. Because here, in the vast unknown, the journey never ends.